Hi, welcome. We are going to find the arc length and the area of a sector. So first, let's think about what an arc length is. An arc length is a part of the whole circumference. Not the whole thing, just a part of it. So the arc length, we could calculate that, and we could actually say that this blue arc is 240 degrees of arc. It's not the whole arc, it's not the whole circumference, it's just 240 degrees of the whole thing. We also, if we know the radius or a piece of information about the problem, we also can figure out how many yards that would be. So if that's 6, I could probably figure out 6, 12, right? See how that's about 3 of those, and 6 times 3, 18, a little bit more. Pretty cool, right? So, but approximating that that's 6 and that's 12 and that's 18 and a little bit more makes 25, there's a way to calculate it exactly. And this would be another formula that if you had it on the test, you could use it, but you'd have to memorize it. And this one's harder to memorize because it doesn't make sense, okay? So make sure that you understand where the formula comes from, and that way you can memorize the formula or remember it if you've forgotten it because you understand what it is. Okay, so what is the formula? Well, it's not the whole circumference, it's a portion of the circumference. What portion? Well, it should be this fraction, 240 over 360, because the whole thing's 360. So an arc length should be this, and you can memorize some crazy formula, or you can just use logic, okay? I would recommend you know how to do both. Okay, but I see how I need to know the circumference. Also, to calculate the area of a sector, so that's something a little bit different. That's this. So to calculate that, I don't want the whole area, I want a fraction of the area. So, and again, it should make sense. I want the same fraction of the area. So to find the area of a sector, I want a fraction of that same area. So notice for every question, we really need either the circumference or the area. And so one way to start every question is with R, D, C, and A. No matter what's the basic information about this entire circle? Well, the circle has a radius of 6, a diameter of 12, a circumference of 12 pi, and an area of 36 pi. You might be thinking, well, how did you get that? But just boom, 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 you're done. To get from the radius to the diameter, you multiply by 2. To get from the diameter to the circumference, you multiply by pi. To get from the area, oh boy, I got to go back to the radius. The area is radius times pi. So that's how I got 36 pi. Now that holds true for every problem. I need to know the circumference so I can figure out what is a fraction of the circumference, and I need to know the area so I can figure out, well, what is a fraction of that area? Okay. So now I'm going to take the information I've made. I have 240 over 360 is equal to the circumference, which is 12 pi, round to the nearest. On this sheet, they said round to the nearest 2 decimal places. So notice there's 2 decimals there, also known as the hundredths place. For the area, I'm going to take that fraction times my area and turn that into a decimal. Okay, and I got exactly the same decimal they did. Ooh, I got slightly different ones, so maybe what's happened? Well, they actually also said to use 3.14 as pi. So instead of using the pi button, I'm just going to use the number 3.14 because they told me to. So 240 divided by 360 times 12 times 3.14. Now I got exactly the answer they got. Now I'm going to do the same method here. 240 divided by 360 times 36 times 3.14. 75.36. Now what's interesting about this sheet is they also show you a little shortcut. If you know the arc length, which they're calling S, you can multiply by the radius and then divide by 2 and get this same answer. Okay, so you can do it either way. I'm going to use the way we've used in class, but you can also use this way, and it's a great way to check. Okay, so let's start problems 1 through 9. If you were in testing this week, you're actually watching this to make sure you know how to do the lesson, but believe it or not, this is the same thing we did last class. So we did this Wednesday, Thursday, and Friday. So the radius here is 17, diameter is 34, circumference 34 pi, 289 pi. All right, so just starting with the general information, radius 19, diameter 38, circumference 38 pi. I'm taking 19 times 19 to get to 361. Okay, so those are all set up. If that's getting redundant, you might be ready to kind of skip a step there. I think I know if the radius is 9, the diameter is 18, so the circumference is 18 pi. If the radius is 9, then the area is radius times pi, so that'd be 81 pi. So I'm okay if you skipped a step, but if you're making mistakes, go back to this, okay? Cool? So circumference here would be 15 is the radius, so the diameter is 30 and the circumference is 30 pi. 15 times 15 is 225 pi. Circumference, if the radius is 6, the diameter is 12 and the circumference is 12 pi. The area would be 6 times pi. This radius is 16, so the diameter is 32 and the circumference is 32 pi. 16 times 16 is 256 times pi. Okay. Radius is 7, diameter would be 14, so the circumference would be 14 pi. Area would be radius times pi, 49 pi. Radius 20, diameter 40, circumference 40 pi. Area is 20 times 20 pi. Okay. That part's done. Now, I don't want to know the whole area of the circle or the whole circumference. I want to know a part of the circumference. So, let's do it. I only want 45 out of 360. That's the only part I want of the circumference. So that is 34 pi. Now, if you're getting a slightly different answer, remember I'm multiplying by 3.14. I'm not using the pi button. Now to find the area. So they did say shade the region. So this is the region they want me to find. So that's 45 over 360 times what portion of my area do I want? Feet squared. Awesome. Actually, I like to go down so you can still look at that question. Okay, so question 4. What portion do I want? I only want 145 out of the 360. And that's what part of the circumference? So that's 38 pi. I want the same portion of the area. I don't want the whole area, I just want that portion. So instead of the whole area, I want a fraction of that. Now, how can I use the formula to double check my answer? Well, they said if I find my arc length, I can multiply by the radius and divide by 2. So I'm going to double check my answer using that strategy. They said I can use that number, multiply by the radius, 19, and divide by 2, and that's what I get. Pretty cool. So that's a great way to double check it. Check out the next video for the rest of the worksheet.